you first of all take this guy and you rewrite him. You rewrite him as x to the fourth minus 9x squared, and that's going to be less than 0. Now it's in the format that you recognize. Here, this says I want y to be negative and not equal to 0, which means that I'm going to have, under the equality equation, they're going to be open dots. So I'm going to go after the x-intercepts on this guy. 4th minus 9x squared equals 0. X squared times x squared minus 9 equals 0. X squared times x minus 3 times x plus 3 equals 0. So x is 0, 3 minus 3. These two guys are multiplicity 1, so they change. This one is multiplicity 2, so there's no change. If I look at the not equal, those are the domain restrictions. This guy's domain's all real numbers, so there are none. And then we put all this information on the number line, which we, of course, we've said is the x-axis. What do we put on? We put on negative 3, open dot, 0, open dot, 3, open dot. Negative 3 and 3 are multiplicity 1, so change, change. 0 is multiplicity 2, no change. Now my second favorite number is available to me, so I'm going to pull a test point. And by the way, I tend to try to circle this, try to move this sucker out of the way, because what happens is if I'm not careful, I begin to include it in my answer. I just do. I do stupid things like that. So I'm going to test 1, and is it true that 1 to the 4th minus 9 times 1 squared is a positive or negative? Well, this is 1 minus 9. This is negative. So negative here. No change. So negative. No change. Negative. Change positive. Negative, change, positive. My answer is in the middle. And notice they're all open dots, which means they don't include those numbers. So it would be minus 3, 0, union, 0, 3. It cannot be negative 3 to 3 because it doesn't include the x-intercepts. That's why I use open and solid dots. Open means does not include, solid means does include. And then that's what your answer would be. So for these x values, one graph is above the other graph for those x values.